Hello, welcome to the team presentation for the final project as part of the course CS6440 Fall Semester Intro to Health Informatics. This is a team of four, Varun, Sita, Arul, and myself, Pradeep. Next slide, please. We have built a basic application that will help user manages medications and help send email notifications. So the purpose of the app is basically to ensure that the user takes his medication on time and also doesn't skip any of his medications. The user should be able to look up medications and also create reminders and maintain his reminders. Initially, the app only supports email reminders, while the architecture and the design is flexible enough to extend to support other type of notifications such as phone messages or notifications or a Slack notification and so forth. The demo of the application is provided here using this link, and we will also be demoing the application later in this presentation. Next screen. The first primary feature of this application is bulk export. So this goes against the OMOP RX norm vocabulary and pulls an approved list of medications that are then stored in the local repository for easy access and better performance, so that when a user performs a search, we don't go to the server every time. The design allows for the list to be updated periodically as well, but this is disabled now because of the error cost limitation with respect to cost. The design also allows for the list to be sourced from multiple sources, so that if we want to go to a different source, that is easily possible. And finally, as stated earlier, we have a local copy of the medication list so that our app's performance is better. Next slide. From a technical stack perspective, we are using Java Spring Boot application for the backend, and for the local repository where user maintenance and remainder maintenance occurs, we use the Postgres database. The application checks every minute. A polling process runs that will check for emails to be sent every minute and then send the appropriate notifications. The API also allows users to create, modify, delete, and view reminders. And again, as explained already, we have a search feature as well for searching up medications, and the design allows for ingestion of other sources as well. And finally, for the front end, we are using Angular and Angular Material. For the deployment, we are using Heroku, and for the capability to be able to send emails, we are using SendGrid's email API, as it is very easy and easy to maintain, and also does not involve other complications of other protocols such as SMT service. I'll now turn it over to Sita for the demo of the application.
Thanks, Pradeep. Let's get started with our live demo. This is our login page. If you're using our app first time, you need to register using the register button below here. Let's register our first user. Like you see, you have to provide your email ID and you can choose your own password. And after successful registration with your email ID, you can log in using that email ID. As you have noticed, we have not have the forgot password implemented yet. Let's try login here. And then this is our first main search page here. Like Pradeep mentioned, you can basically search for a medication to help add a reminder for the medication. Let's see the registered user using the view user profile. So this displays all the information about the user that you have just registered. Currently, we allow you to edit your name because that's the only information that we are accepting right now. Yeah, let's try editing the name here. You can see the name is updated properly. And let's go back to the search medication page. Yeah, let's try one search. Yeah, like you can see, there is no medication named demo in the OMAP FHIR database. That's why you're getting the error. Let's try with one medication, valid medication name. Yeah, so now you can see our search results are displayed on the same page here. So here are the search results from the OMAP database for the medication that we searched for. So you can scroll down and pick the proper medication that you would like to add a reminder for. So I will hand over to Varun to show you how you can add a reminder from one of the medication from this list.
You can see that, yeah. So then the user can also go ahead and provide the complete search term to filter the results that they want. So they'll only see ibuprofen. That's added for ibuprofen, 400 milligrams. And then once they click add, they'll be navigated to the add reminder page. From here, they have to select one of three frequencies: once, daily, or weekly. Once means it'll send a reminder on a particular date at a particular time. So right now, my current time zone is 10:01. So let's say I want a reminder sent at 10:01 in my time zone, which is Mountain Time Zone. And I can keep the existing name. As you can see, it's pre-populated from the previous page, or I can update it if I want. And I can add a reminder. Once the reminder has been added, they'll be navigated back to the view reminders page, which has medication name, frequency, and some action buttons, which we'll cover a bit, but this gives a quick overview. So let's go ahead and continue our demo on the daily reminder. Daily means the user will be able to get a reminder every day at the time they provide. So again, 10:01 is the time that they want, the time zone I can say. And this time, if you come from over here, you have to provide your own medication name. So let's say I want Tylenol. I can go ahead, save it. The daily reminder starts the next day from the day the user has created. And again, that's been added. And now let's try what happens when we do weekly. So for weekly reminders, the user gets the option of selecting which day of the week they want. And then every 7 days from that day, they'll get a reminder at the time that they specified. So once again, over here, let's say the 10:02 a.m., select time zone. They have to provide the time and the time zone. Same thing here. Ibuprofen, doctor prescribed. And then this is your weekly reminder. So what this means is they'll get a weekly reminder Monday, Wednesday, Thursday, Sunday, that they can add a reminder. If the user wanted to add multiple reminders for the same medication for a given date, they can go search medication, again, search for ibuprofen, select add, and then they can select once or daily, and they can add it for another time. So let's say 10 p.m., whatever that they want. And this is how we support the functionality to have multiple complex reminders a day. This can be updated in the future. So from here, what you'll see is we can go ahead and check. You can see that I got the reminder to take the daily reminder, ibuprofen once. This the time zone here. This is the Eastern. I'm in Mountain, so that's a 2-hour difference. But we selected at 12:02, and the time zone is present over there. Finally, the user can then go ahead and update their reminder times. They can change the time for daily. For weekly, they can select the dates and the time that they want to do, the time zone. And they can also delete a reminder that they no longer want. So let's say ibuprofen weekly, they want to delete, they can delete. Once they've deleted the reminder, it populates away. They can go back, update, and you'll see that they have a confirmation that it's been updated properly. Updated successfully. From here, the user can log out, and we support multiple users in the system, so there's a different user. You'll see that they have different set of reminders. Same functionality, they can search, update however they want. And that's the basic demo that we have. I can now pass it over to Arul, who will continue over to the next part of the presentation.
Thank you, Arun. So to conclude, as you see in the demo, a fully functional app that can send email reminders based on a user preference was developed by the team. The application is also able to ingest data from the external medicine list and make it searchable, as you've seen in the demo. So here are some of the challenges we faced while implementing this app. First, creating a pipeline that can convert and transform the external data for the internal use. Next, the ORX-norm full vocabulary was a huge data set. And seeding the data required large instances than we originally thought. Finally, when we deployed the app, we found that Heroku's lack of native support for monorepos, where the front end and back end resides in the same repository. So we had to split the monorepo into separate front end and back end repos in order to deploy properly. Next slide, please. So here are some of the potential improvements that can be done to this app in the future. In addition to email reminders, which we have developed, we can also do the text or SMS reminders, which can be sent to the user phones along with the email. And we can implement a forget password feature, and we can implement a snooze function that can repeat the reminder till the user acknowledges that the medication has been taken. And also allow additional users to be added to the same account, so that in case of a family member or a caregiver wants to keep an eye on one of the patient's medication, they can do that. Next slide, please. So also one potential feature which we thought about is like integrating this application with the drug-drug interaction API provided by the National Library of Medicine. So this is done to notify conflicts when a patient add a new medication. He can see if it interacts poorly with any current medications, and it can notify the users about that. So another enhancement we thought is enhancing the app to provide the ability to pull the prescriptions directly from the EHR vendors, or by uploading the image of the prescription that can be converted to reminders. And also provide an admin interface API where an admin can manually upload the medicine list through the UI screens. Finally, we can create a CI/CD pipeline for faster testing and implementation of this app. At this moment, it's been done manually. So this ends the presentation slides. Thank you.